So we're gonna go to your next presentation, shake table testing of precast UHPC bridge column with ABC seismic connection.
Right.
Please.
So, thanks again, Dr. Mahrabi. So that's like my own project. So maybe I know a little bit more about this project than the other one. I have two PhD students working on this, Ellen and Milena. They have been my recent ABC UTC champions. Maybe for those of you who know me, like I try to have several ABC projects, or maybe a cohort of students working on different ABC projects, so that we put all these small projects together to make up good dissertations and larger contributions. So Ellen and Milena, they're working on several UHPC projects and initiatives. Some of them are ABC related, some of them are not, but we have also we try to always leverage ongoing projects. So for this project, I have to acknowledge, of course, the funding from ABC UTC is always, we're always grateful, but we have also a precaster here in California who helped us build the specimen for this project, as you'll see towards the end of the slides. And we have also CoreTurf provided some of the components for the UHPC that we used in this project. So I just wanted to acknowledge our sponsors, and industry collaborators before we start. So the first 10 slides or so maybe are repetitive, and I will go over them quickly just to create the context. We know that UHPC is growing and making huge strides in the US. We know that UHPC is almost the go-to solution now for many of the ABC connections, and because of this, the market is just continue to grow. 10 years ago, we had only maybe 1 or 2 vendors in the US. Now we are talking about at least 4 or 5 commercial vendors in the US, and a whole bunch of non-proprietary mixes that are also available for use in many of the state DOTs. So if the market is growing and there is always, ways to innovatively use UHPC, what people have have been doing beyond the ABC connections, the federal highway here in the US, they are looking at full precast and pre-stressed girders. We know in the pre-stressed world, we have this 0.7-inch strands that are, emerging in the last 10 years or so. If you take the best in the pre-stressing world, if you take the best in the reinforcement, and you take the best in concrete, which is UHPC, in my opinion, how we can, rethink our bridge girders. And what the federal highway, they are looking at what they call it the mega or the ultra girder that can be envisioned that can go up to 300-foot span in one piece. There might be challenges for transportation and so on, yes, but at least from a structural point of view, we can have really new opportunities if we were to account for the right properties of UHPC. In Malaysia, they have already, used full bridge girders using UHPC, maybe up to 230 spans. In even the Precast Institute here, they try to, do several H2 type, girders, and the Federal Highway is still doing several even girders. So between the Precast Institute, the PCI, and the Federal Highway, there are so many girders. But if we are looking at this, most of the applications have been really confined into this girder, thing. Columns is not as, well studied or explored as girders. And when we talk about bridges, we have, columns are the main structural system for lateral loads and for other things. So if we can do this for decent superstructures, why don't we do it for lateral load resisting systems as well, and vertical components? So we have been looking into columns. We have did some exploratory work for bridges, from an analytical perspective, for tall buildings, even you can have long, slender UHPC columns that could be comparable sometimes to composite sections. Maybe it might not be as high of a capacity as composite sections, but it is comparable. So we had an ACI project that looked at slender UHPC columns for tall buildings and so on. So columns have been promising, and what we are always trying to do here at UNAR is that if we were to replace normal strength concrete column with UHPC columns, what would be the dimensions, what would be the design philosophy to use, and so on. So we wanted to, we did this so many projects in the past on the axial components mostly, or the axial loading mostly. This was our focus, but through the ABC UTC, maybe even the very, very first center in 2013, in the very last cycle of this center, we completed a project in 2018, and this was my first project on seismic UHPC columns. And we did an exploratory study just to make sure if this UHPC can work for seismic columns as well as conventional building columns. And the results were impressive. We were just impressive. We were able to show that UHPC with the right design, as long as you do the right design, can provide the right ductility and the drift capacities and the displacement capacities that we use. And we even try to marry UHPC with high strength steel, and we showed that even yes, high strength steel is a little bit brittle, but again with the right design, you can get to acceptable, ductility and drift ratios as far as the H2 is concerned, or something like that. So we did this project long in the past, and it motivated us to continue to use UHPC for columns. What we wanted to do is to extend this to precast. So we wanted to, a full UHPC column that is precast. So to use a precast column, you have to use it with ABC connections. That's how seismic, work. Like if you have a precast column, as long as it's precast, not cast in place, it has to be either connected to the footing or to the cap beam. And either way, you need an ABC connection. So we have ABC seismic connections, as I said, and we wanted to see if we use ABC connection and UHPC, full precast UHPC column, how these two together will act, will work. We have never studied this before, and no one has looked at this yet. So we wanted to explore the different seismic connections, which ones will be more appropriate for UHPC columns, try to design and construct a full precast, the conventional concrete footing, because the footing maybe doesn't need to be UHPC. So if you have a conventional concrete footing and UHPC column, how to design it so that you have the failure still in the column as intended from the seismic design philosophies that we adopt here in the US. And we wanted to do a shake table testing. So we wanted to try so many new things here. The connection for the UHPC column when you have the full UHPC column, because there are many ABC seismic connection tests that were done before, but none of them used a full precast UHPC column yet. We did, even the project that I just mentioned, it was a smaller scale, it was cast in place columns, but also it used static loading or quasi-static loading. What is the dynamic behavior? We have all these, fibers and tensile properties, and you have, some of these things that might be a little bit more sensitive to the rate of loading, unlike conventional concrete, for example. So we needed to do some seismic tests, a shake table dynamic test as well. So in this project, we wanted to confirm which seismic connection to use. We wanted to use the best mixture for the UHPC, and then do the experimental program and testing. So before I proceed with the progress, we are, a little bit behind in this project because of the construction of the specimen. That was the most, significant task that took almost a year, more than what I anticipated, to be able to get to work with a precaster and get an actual precaster to build the column. So the good news is that we just had the column built literally a couple of weeks ago. So the other thing is that I tried to couple this project with a new project that hopefully we will start in cycle 6, which is supposed to start hopefully in the next week or two from the center, and so that we can even grow the scope of this further and test more connections, test more columns, and do much more than what we can do in this project. So the two seismic connections that were found to be promising is the grouted duct connection and the full socket connection, where you have the full precast column, a full precast footing, and you just have the interface. Some of the NCHRP projects that were completed here at UNR a few years ago, Dr. Saeed, led some of these, provided some guidance on the ABC seismic connections, and you can do these connections with UHPC, fillers, or even with grout or standard concrete. So some of these connections can even be generic enough that you don't need only UHPC for the connection. You can use standard grout as well. For this project, we are hoping to use UHPC for the connections. But these are the two connections that we wanted to try. One of them has been already implemented several years ago in California in one of their ABC pilot projects. I think the ABC ETC has hosted Caltrans a couple of times, and you guys might have seen this in other webinars that the ABC UTC has provided. So you might have seen this already. So it's an actual bridge in California that they have used this connection. So these connections are already practical. They have been implemented already. So would they work for UHPC columns or not? That's what we will see in this project. The task that was not even intended to be part of this project, and it became a huge part of the project since we were able to leverage a lot of our other ongoing projects, is what's the latest or what's the new in the UHPC world in terms of which mixture to use for these columns. We have been working, with all 4 or 5 vendors in the country. I'm very, very grateful that I'm working with Lafarge, Cientic, Kurtov, Steel, every single UHPC that's available in the market. We work with them, so we have access to all these materials. We wanted to know if this, which one, maybe is more likely to be a better solution for columns. So we tried the carbon nanofiber UHPC. This is supposedly the next generation of UHPC with all the advancements in it. So Cientic, they do a commercial carbon nanofiber enhanced UHPC. So we did some, material characterizations, and we did a lot of, even axial column testing. So I don't want to go into the details of this. We did even a local study on confinement to see if these could be a viable solution for seismic. Like seismic and confinement, they go hand in hand. We would like our seismic columns to be well confined. So we did some, side study on a small scale, and we found out that yes, this is a great material. I don't want to compare. I don't tend to compare materials because each material is great as long as you find the right application for it. But we found that for the cost and purposes, and for the enhances that you get from the carbon nanofibers are not really something that would be manifested at a full precast column level or bridge column level. So we decided not to proceed with the carbon nanofiber for this project. We tried something else. We knew that we have fully non-proprietary UHPC, including the one that we have developed collectively. Oklahoma, developed a mixture that we adjusted here at UNR, and we used it. And we have been doing a lot of work on non-proprietary UHPC, but there is also semi-proprietary UHPC. So what we wanted to do for this project, since we have tried the non-proprietary UHPC before in many projects, we wanted to try the semi-proprietary UHPC. So what's the deal with the semi-proprietary UHPC? These are just some of the work that we did on the non-proprietary. So this slide is just to confirm that there is a lot of work that was done on non-proprietary UHPC, and we didn't really need to, do that much. We know it will work at the column level, but we wanted to see if it could be take advantage of this project to try something different, and that's why we decided to do the semi-proprietary one. So why is it semi-proprietary, or why do I choose? I personally call it semi-proprietary. It's not a conventional way of calling it, but Kurtaf, for example, that's one of the vendors here in the US. They actually give you the magical part, like in the proprietary components or so, which in Kurtaf's case is just a dry mix that has their own, secret materials or whatever, like silica fumes, fly ash, whatever, fine materials they use with their own, ingredients and proportions that they don't reveal. But they provide you this proprietary component, and they tell you you can use it with any cement, any sand, any admixture. And this was the case. Was it verified before? No. So we step up and we took advantage of this opportunity, and we did a very comprehensive study to look at the effect of different sands with different fineness. So do you really need to have graded sand or fine sand or coarse sand would work? Does the moisture, natural moisture effect of sand? Because in precasters they just sample the sand, do a moisture test in the morning of the mixing, and they just mix. So do we have the flexibility for UHPC, or it's very sensitive to these type of sands and moisture? Cement, type 1, type 2, type 5, which does it make a difference? Admixtures, we have several commercial admixtures, like Sika, for example, Criso. These are big, giant companies that they provide a wide range of mixed admixtures. So does any of these admixtures work or not? And more importantly, the fibers as well. The fibers is the most expensive component. So we are even looking into recycled fibers, and we'll do this hopefully in the next project when it starts soon. So we wanted to take advantage, and I think the semi-proprietary UHPC can have the benefits of both. The cheap, cost that is associated with the non-proprietary UHPC, because you can local your own source. You can source your own sand, cement, even fibers. You might have a little bit of benefits on sourcing your own fibers if you were to do it using recycled materials, for example, or local producers. So you don't have to ship across the country trucks and trucks of the entire material. You can just ship the semi-proprietary, the proprietary component, which is the one that will be in, I would say, in charge, or the one that we need for scalability, for robustness, because these are some of the aspects that we are lacking with non-proprietary UHPC. When you scale things up for non-proprietary UHPC at a scale, you don't get the consistency, you don't get the right mechanical properties that you were hoping for. So the semi-proprietary can combine the the effects of both and eliminate the weakness of both. The cost and the scalability issue, these both are eliminated when you do semi-proprietary UHPC. So we decided to proceed with this. As I said, we tried different fibers, we tried different admixtures, different cement, and we did a whole bunch of material tests, and we were able to settle on a version of the semi-proprietary UHPC to use for precast application. And that's just recent. We have only concluded this recently. So what do we want to do next? Now that we have a material that we want to use, we wanted to test this. So that will be the test setup. We are not there yet, but this is how we will test it. As I mentioned in the previous presentation, when you do seismic testing, you need additional masses because the column is part of a superstructure. Here at UNR, we have a setup where you can put the lump mass aside from the table and they work together as one system, but this works only when you're doing horizontal shaking. If you're doing vertical shaking, this doesn't work. So what did we do about the specimens? We finalized the design of the specimens. We wanted to design both a socket connection, and a grouted duct connection. And in fact, although we promised to only do one column in this project, we hopefully will try to do more than one, especially if we combine it with the next phase from cycle 6 project. We will try to do both. So we designed the columns, we designed the conventional footing, and we worked with Confab as a precaster in California. That's 3 hours away from here in Stockton, from Reno. And we consider 2 different mixing methods. Their production scale pan mixer, which is 6 cubic yard, and their ready mix trucks, where they can load materials into the ready mix truck and mix things. So we tried both, in fact, for some of the trials, and we successfully 2 weeks ago were able to fabricate some columns. So this is the fabrication setup. They used one of the precast trenches. They set up the columns in the trench, and they have access to the top of the column so that they can pour it from the top. And here, we did the UHPC mixing and pouring using the ready mix truck. So this is some of the material, like we loaded the fibers, for example, to the truck. We loaded the sand and cement using the precast conveyor belts, and we were able to get very viable UHPC. Here is the flow test. So the material worked just fine, and they were able to build the column. So this again is very fresh. This is only 2 weeks or so, ago. And this is the columns that we built. So they just stripped the formwork a couple of days ago, and this is how the columns look. So we built 3. This is the one with the pocket connection. This is the one with the grouted duct connection. We are hoping to build the column, the footings in the next few weeks, and hopefully later this year we will do the testing. So what will come next is that we will, once we complete the footing, we will assemble the columns. We will test them here at UNR, and hopefully we'll be able to deliver this. But as I said, since we had this opportunity to work with a precaster, and because of the limited resources, you cannot do this much with 1 year project or with budget, from a 1 year project. We decided to hopefully, the center will use this, and hopefully the new project will start soon. But we will leverage this and do a second phase, if you will, to try 2 types of connections, to try seismic and static loading, and even the precaster, they are willing to come back and help us build new set of columns with recycled fibers and so on. So that will be coming soon. So hopefully next time we will present this project. It will be hopefully done by then, and maybe some of the ongoing work on the next project as well. So that's what I had to share with you today, and I would be happy to take questions.
Thank you very much, Dr. Mustafa. And you show this beautiful picture every time and make us envy your facilities there. Yeah, thank you. It was great presentation. A couple of things that wasn't clear. How many column specimen totally will be? Because you said originally you intended 1. But...
Yeah. So what we have now, at least 2 that we will test on the shake table, and 1 that we will test outside the shake table. These are with virgin fibers, and my goal is that to have 3 more identical ones, but with recycled fibers. So if we combine this project hopefully with the new one, we will have a total of 6 to 8 columns. That we will do more, work with the precaster. So they are willing and waiting for us to decide on the final number of columns. So my goal is to hopefully push so hard and try to get to 8 columns, even if I can.
That would be great. One other question about semi-proprietary mix. Are these mixes tested, or do we know well the semi-proprietary?
Yeah, so so the Kurtoff in general, what they do, if they were to sell it, they can provide you with everything, right? So they can provide you with the cement, with the sand, with the admixtures, with the fibers that they think, based on their own R&D, that this is the best set, for example. But they also provide the flexibility that you can use your own sand and cement, and they just give you the standard material, properties that you should expect, and it's up to you. You do your trials, so that's what we did. For example, when we tried sand, let's say very fine graded sand versus very coarse sand, we show that the strengths, yes, of course, will vary, but within 5%. So if this is something that I can accept, why not? We showed the same thing with the cement. The precaster, they use type 5 cement, type 2, type 5 sometimes. Your UHPC usually use type 1, type 2. So when we vary the cement a little bit, how does this affect the early strengths? How does this affect the hydration process, and later on affect the full strengths? it has an effect, yes, but again, the effect was found to be very minor or negligible. So these materials have been demonstrated to work, at least locally. We have, even in our labs, I don't know if I'm including this here, I think we did 30 different versions of the materials, 30 different batches of this material with different sands, different cements, different everything, admixtures. So, and we showed that within the 30 trial batches, the variation in total was maybe less than 5 to 10%.
Thank you, Dr. MOUSTAFA. Great presentations.